Advanced Algebra 2B. So these notes are going to be in the same section as before, so 11.1b, finding measures of central tendency and dispersion. And we're going to talk about two different concepts today, the first of which is standard deviation. So make sure, please, that you write this definition down in your notes. Standard deviation, which you may have heard before, is a measure of dispersion or spread. So it's telling us, it's a way to tell us how spread out the data is, which describes how far the typical data point is away from the mean. So basically it's telling us, you know, if we looked at a bunch of data points, how far away are most of the data points from the middle. So it's another way to talk about how spread out things are. By the way, today in the notes I'm going to be using two symbols. The X bar you've probably already seen. We saw it on our calculator and the notes from last night. Whenever you see an X with a bar over it like this, what it means, it's standing in for the mean or the average. Go ahead and write average there. And then this little symbol is like a circle with the bar coming off of it, is the symbol we use for standard deviation. And this little symbol is called sigma. It's actually a Greek letter that gets used in math a bunch. So whenever I say sigma, this is the little guy I'm talking about, and we're using it for standard deviation. Now, standard deviation has a formula that's kind of funky, and the first thing you have to do with standard deviation is find the mean. So for these quiz scores that I've got, these hypothetical quiz scores, the first thing I want to do, step one, is find the mean, or X bar. Okay. Now to do this, I'm going to go into my graphing calculator. Let's see, that's from something else, so I'm going to clear it out. Go into my stat, hit enter on edit, and I've got some numbers plugged in here already. In fact, I think these were the ones from last night. If I want to clear these out all at once, I can just move my cursor up to L1 and then hit the clear button, which is right beneath the arrows, so this clear button right here, and then hit enter. And it will clear all those values for me. So now I want to enter in the numbers I see for my quiz scores, so 18, 20, 14, 15, 20, 17, and 16. Okay. And then I'm going to hit stat, go over to calc, hit enter on one variable statistics, and enter on calculate. So this is just like last night's notes. And notice in the calculator it gives me X bar is 17.14. So using my calculator, I got X bar is 17.14. Okay. Step two, to do this by hand, you're going to need the formula for standard deviation. Now that formula says that sigma is equal to the square root, make it a big one, of your first data point minus the mean, so X bar squared, plus your second data point minus the mean squared, plus your third data point minus the mean squared. And you do this with all of your data points, so all n of your data points. And then you divide this whole thing by n, by the number of data points you had, and you take the square root of that. So to do this out by hand, our standard deviation for this problem would be the square root, and it's going to be a long one. Okay. I take my first data point, which is 18, minus the mean, 17.14 squared, plus, then I take my next data point, is 20, minus 17.14 squared, plus the next data point, minus the mean squared, plus the next data point, minus the mean squared, I'm going to have to keep going, plus the next data point, minus the mean squared, plus the next data point, minus the mean squared, plus the next data point, minus the mean squared. And then all of this, once I figure it out, has to be divided by n. And then we're going to square root it, which is gross. Okay, So we go into our graphing calculator. If you don't have a graphing calculator, this problem is going to take a lot more time. And now I need to start figuring out what all these numbers squared are. So let's see, I've got to put this in a place where I can actually read my work. 18 minus 17.14 squared plus 20 minus 17.14 squared plus 14 minus 17.14 squared. Ugh. Hope I'm not making any mistakes here. You guys can probably see my mistakes faster than I can, huh? So let's see, if I go back up, I've got 1, 2, 3, 4, 5, 6, 7. So for me, that means n equals 7 because there are 7 data points. So I'm going to be dividing this by 7. So I take all of those numbers squared and added together, I divide by 7. And then I take the square root of this. So second square root, second ANS. And I get 2.166. We can round this to 2.17. So when I work the math out, I get 2.17 for my standard deviation. What this means is if I look up here at my numbers, the mean was about 17, right? So the middle of all these numbers is about 17. This means that your average data point is about 2 away from 17. So like you go about 2 higher, well that makes sense because 2 and 17 make 19 and my highest number is 20. Or about 2 lower than 17, 17 minus 2 is 15, yeah, that makes sense. Most of the data points are between 19 and 15, with a few exceptions. Okay. Now your graphing calculator can do this for you a lot faster, and in fact it was actually already pulled up. If I hit stat, calc, enter, go down to calculate, okay, notice 2.17 is sitting right here, that 2.1665. So your graphing calculator, as soon as you enter the numbers in the list, is actually spitting out your standard deviation for you. So this little sigma of x on your graphing calculator is 2.1. You could round that to 7. So if you have a graphing calculator, you get to avoid step 2 the long way. This is step 2 without a calculator, without a graphing calc, which is not fun. And you can do step 2 with your graphing calculator, which just amounts to plugging in the data points and then hitting stat, going to the calculate menu. So let's see, let's look at that again. So you hit stat, you go over to the calculate menu, you hit enter on the 1 var stats, and then you just look for sigma x, and that tells you your standard deviation, which is so much happier. So the moral of this story, if you don't have a graphing calculator yet, go get one tomorrow morning. Go get one at lunch, borrow one from a friend, but whatever you do tomorrow, show up to class with a graphing calculator. Now, the other thing that we need to do for today's notes is talk about outliers. So if you would please copy down the definition for outlier. An outlier is something you've actually probably heard about too before. This word probably makes sense. It's a data point that is much greater than or much less than the average. And you guys know this, like if a kid walked into class and he was 7 feet tall, he would be an outlier because he would be taller than most of the kids. He'd be way outside the average for what a height is for a high school kid. So in this problem, we've got some winning scores for an air hockey tournament. I don't know, I'm just copying this problem out of the book. We're just using a book example here. So we've played some games in an air hockey tournament, and these are the winning scores. Now, I want to find the mean, median, mode, range, standard deviation, but I don't want to have to do a whole bunch of work, so let's go into our calculator, go into the stat menu, clear the stat menu out, and enter these digits in. So 14, 15, 15, 17, 11, 15, 13, 12, 15, 13. Okay. Now I'm going to hit stat, calc, 1 var statistics, everything's hunky-dory, and now I just have to read the important information off my calculator. So the mean is the x bar, so the average of these numbers is 14. I have to scroll down to get the median. The median is 14.5. The mode I have to just get by looking, so let's see, 15 occurs 4 times, so 15 is my mode. My range is my biggest number, so 17 minus my smallest number, so let's see, that's 11, so it's a range of 6. And my standard deviation, if you recall, is that little sigma x on your calculator, so 1.67. Okay. Now, this is all stuff we know how to do. The important thing here is what would happen if we introduced an outlier. So for instance, if I said one of the winning hockey scores was 25, this is a number that's quite a bit bigger than everything else in the list. And I want to see what happens to the mean, median, and mode if I add that digit in. So if you used your graphing calculator, this is really fast and easy. You just go into your stat menu, you scroll down to the last number, and you add that extra digit in. So 25. Then you hit stat, go over to calc, enter, enter, enter. And now you can see your new statistics. So here we've got 15 for the mean. We've got 15 for the median. The mode is still 15. The range, however, now is 25 minus 11, which is 14. And the standard deviation, let's see, is 3.54. 3.54. Okay. So by introducing this outlier, this data point that was way bigger than the rest of the data points, the mean didn't change very much. Neither did the median or the mode. These measures of central tendency, these are measures of center, right? The center didn't really move that much. The average, the middle of these numbers, is pretty much the same. The numbers that did change are the measures of dispersion or the spread of the data. Notice that it went from a range of 6 to a range of 14. They really spread out. And then the standard deviation really spread out also. Okay. So that's it for notes tonight. Make sure you get everything written down, all of the vocabulary words, and really make sure you actually listen to the video as you're writing things down so that you don't just get the picture, but you get the words behind it too. And then I will see you guys in class tomorrow. Oh yeah, and don't forget, get your graphing calculator tonight. Thanks guys, bye.